Okay, this figure 8.1 shows a ray diagram for a scene converting lens. The lens forms an image of the object. The object is positioned 30 cm from the center of the lens. Determine the distance of the image from the center of the lens. Use information from the image distance. Yeah, which one is the image? This one is the image, right? Yeah, this one is the image. And this one is the object. The question is the image distance. What do you think the image distance? It's the distance from the center of the lens to the image. So from there to there, how many centimeters there? Of course, 8 plus 3, right? Yeah, 8 plus 3, which is 11 centimeter. 11 centimeter is equal to 0.11 meter. So this one is the image distance. Image distance usually noted as accent, and the distance, object distance, is this, usually noted as s. So to find the focus length, which is the equation is 1 over f is equal to 1 over s plus 1 over s accent. This is the focal length. Okay, so see another question. Determine the focal length of the lens. Use the information from figure 8.1. So what is the focal length from this information? The focal length based on this formula is 1 over s plus 1 over s accent, 1 over the 1 over the object distance, which is s. So s is object distance, which is in meter, and s accent as image distance, usually also in meter. And how about f? F is focal length. In meter. So if we want to find the focal length, of course 1 over f is equal 1 over s plus 1 over s accent, which is 1 over 30, because s is 30, plus 1 over s accent, which is 1 over 11. Can you find what is f from this equation? Yes, it's 8, but 8 centimeter should be converted to meter because the answer is in meter, right? So
Yeah.
it has to be 0.08, right? Next one, state two characteristics of the image formed by the lens. This is the image formed by the lens. Can you mention the characteristic of the image? Is it smaller than the object, or bigger, or diminished? Which one? Object is like this, image is like this. That means that smaller, right? It's higher, bigger, smaller. So the characteristic of the image formed by the lens is smaller. Smaller. What else? Any more besides smaller?
Mm, um, it's all there.
This object is upright, right? Upright. But the image is in what? We call it inverted. Inverted. So smaller than the object, and then inverted. What else? This also can be captured by the screen. The image can be seen by the screen. So we call it a real image because it can be captured by the screen. But if this is virtual, virtual means that the image cannot be captured by the screen. So we cannot see the image if virtual. But if real, we can see the image on the screen. So yeah, smaller and then inverted, and yeah, if can, number 3 is real, like this. Any questions so far, Seno?
No.
Okay, so this is about the spectrum. Figure 8.2 shows levels for part of electromagnetic spectrum in order of decreasing wavelength. Started from visible light going to the right, ultraviolet, and then yeah, can you mention what is here and here? The name. The order is this. Started from radio waves, which is the smallest wave, the smallest frequency. This one is the frequency. Sorry, this one is the wavelength. Yeah. And then going to the microwaves, and then infrared radiation, which is remote control, visible light, which is raw GB, red, orange, green, blue, indigo, violet, and ultraviolet. We started from this just now, right? And then going to that, which is X-rays and gamma rays. Okay, so this is the spectrum of electromagnetic. Now we back to the question. So do you remember after ultraviolet is what in here? After ultraviolet is this ultraviolet, right? X-rays, right? And then going to the right again is gamma rays, which is the highest frequency but the smallest wavelength. This is a wavelength, very very small, 10 to the power of minus 13 meter. So we can write here after ultraviolet is X-ray, right? X-ray. After X-ray is what in here? What is what is after X-ray? Decreasing wavelength. Can you mention? It's the highest frequency. Which is gamma rays. So you can write double M gamma rays. So from visible light to gamma rays, the wavelength is decreasing but increasing in frequency. Each of them has use, which is radio waves to hear radio, microwaves to bake cake, infrared radiation for remote control, visible light, the lamp, ultraviolet from the sun, X-rays is like the radiation of chemical substance like radium, uranium, and also another sodium. Okay, any questions so far so now from this spectrum? No? Okay, step one use of ultraviolet radiation. Can you mention what is the use of ultraviolet radiation? It's in medical treatment.
X-ray.
Now for ultraviolet, this question, what's the use of ultraviolet radiation? One of the use of the ultraviolet radiation is in a medical situation to sterilize. Sterilizing, sterilizing wood, like sterilizing canned food, canned water, or canned medical instrument. So they use ultraviolet to sterilize. All ultraviolet radiation can also use to detect the fake nodes. Can also to detect fake bank nodes. It says can number one, can number two, but only one, yeah. You can choose which one, this or this maybe. State one danger to people from excessive exposure to ultraviolet radiation. State one danger. If we get the excessive exposure, also we will get danger. So yeah, what is the danger? Maybe you can give idea. What danger is this? The danger is it can damage what? Damage to skin. Yeah. Or even we can also damage to our eyes. If we get excessive mean like too much ultraviolet radiation on our body, so our body will get damage, especially to the surface of the skin and also eyes. That is ultraviolet radiation. Okay, Chanel.
Yeah.
Okay, now we go to the next question. Figure 7.1 shows a ray of light striking a plane mirror. The ray is reflected as shown. Is like this. Ray of incident going, this is the plane mirror, of course will be reflected. This is the normal. The angle of incident for the ray of light is 40. The angle of incident for the ray of light is 40. Where is the angle of incident? The angle of incident is the angle between the incident ray, which is this one, the ray when come, and the normal. So we can note this as 40 degree. So this is called the angle of reflection. Indicate the angle of reflection by drawing a letter R on figure 7.1. Or the letter R, yeah. So just write R on here. This one is R. State the size of the angle of reflection. So this is angle of reflection. What was the size? If R is 40 degree, what is angle of reflection? Indicate the angle of reflection by drawing a letter R on figure 7. State the size of the angle. Yeah, of course the size is 40, right? This is the angle of reflection. Angle of incidence. Sorry. This one is angle of incidence. Yeah? So angle of reflection is this one, which is R. And the R is 40. So what is this? This one is angle of incidence. So I is angle of incidence. R is angle of reflection. If this happen on a plane mirror, so I is equal to R. This is the law of reflection. The law of reflection said that the angle of incidence, which is I, is equal to the angle of reflection, which is R. Okay? So get next. An object O is placed to the left of a thin converging lens. This is O. F1 is the principal focus on one side of the lens, and F2 is the principal focus on the other side of the lens. The two rays from the top of the object are incident on the lens, as shown in figure 7.2. So this is the ray. This is the ray. On figure 7.2, locate the image of O by continuing the path of each ray. Locate the image of O by continuing the path of each ray. Maybe you can give description how to answer this question.
Mm.
There are three characteristics. Yes, like how?
Um,
Okay, the first one, let's say this one is the first ray and second ray. The first ray will be like this. It will be refracted, right? It will be refracted towards the focal point, like this, in this direction.